welcome to Continuous Evolution Talk. So let me start with a question. Who of you have a struggle trying to justify some of the technical work required to modernize your software? Me too. In all my experience as in the software industry, as a software developer and as an architect, I have been facing those challenges, trying to promote these technical initiatives across business and product stakeholders. That's why now, as head of architecture at the workshop, I have been given the opportunity to work in a framework first that is able to assess the status of these products and actually can help us to drive those difficult conversation with our stakeholders. Why continuous evolution? Well, we at the workshop, we are a product-centric organization, so we deliver products that needs to operate in a 24/7 mode and that they have a long life, so we cannot afford, let's say, building new platform or replacing those products every now and then. So we need to focus on keeping them up to date, maintaining them. In our case, it's more evolution than revolution. So in this talk, I will try to present what are the challenges with software evolution, follow up by the existing techniques in the software industry to tackle those problems, mainly evolutionary architectures, and we'll finish with the presentation, the introduction to the framework that we have implemented, using those concepts of evolutionary architecture to assess the state of our products and evolve them, and try to evolve them. So let's get into the software evolution challenge. So who of you agree with that statement? So software products never degrade over time. None? Good. I mean, I actually think the software product degrades over time. So I agree with all of you. It's not that software products or the systems in a vacuum, they just degrade, right? So, but they do because they live in a dynamic ecosystem and they are exposed to external conditions. External conditions like new business requirements, shifts in demand, new technologies, new vulnerabilities, or new security attacks. And actually, new changes over changes that you need to implement in the code that makes the system more brittle over time. So let's illustrate this with an example, a non-software related example. So imagine a new area under development in a city, in a town, where where families start to set up and they start building their houses. The first family gets there, they build their house, they connect the house to the sewage treatment plant, and at that point everything is okay, right? But as this area evolves, the demand also grows. So maybe let's get to the initial slide on this, on the example. So I was saying that, so imagine this area, right? So new area in a city, in a town that is being developed, is under development. So first, families set there, they build their house, they connect their house to the sewage treatment plant, and as we said, everything works perfect. However, demand grows. So I say that it's an area under development, so we start seeing more houses, more being built, and more families being set there. And obviously, the problem starts to appear, right? So you see that there are leaks in the pipe. So what do you do? You just need to adapt to the current demand. So you can build new, you can replace the existing pipes with bigger ones. However, when you find that the new pipes, the new bigger pipes, you found out that they are made of different material. The technology has changed. So wherever it was made of plant before, the pipes, now they are made of plastic, right? So you need to change all the connections. Additionally, as we move to more eco-friendly, let's say, sewage treatment plant, again, you need to adapt to those changes. You need to, again, change the connections. So with this example, what it illustrates is that basically our systems, just change because the external factors, those external conditions I was mentioning before. So the same applies to software. The same happens with software. So you may be thinking, what are the existing techniques in the software industry that can help me to tackle those problems? I will go through the main one, which is called evolutionary architecture. So as defined by the authors in the book, Building Evolutionary Architectures, an evolutionary architecture is that one that supports guided change, incremental change, and across multiple dimensions. So with incremental change, probably it's something more common to most of us because we used to use agile methodology, which actually promotes that incremental change. But I will focus more on the other two, the guided change and multiple dimensions. What do we mean with guided change? With guided change, we mean some sort of mechanism that allows you to measure how the changes impacts to the characteristics of your software architecture. That's why they invented this concept of architectural fitness function that in the evolutionary architecture technique that basically does that, right? Just measure that mechanism that measure how the changes impact your architecture. And what do we mean with architectural characteristic? This is what we saw in the definition. Let me go back. So, definition about multiple dimension. So, architectural characteristics are those dimensions. Some people call it like quality attributes, non-functional requirements, or architecture significant requirements. I provide here just a subset, a list of the architectural characteristics. You may have others in your products, but these are the ones that are in the ISO standard 25010, just as a reference. Going back to the fitness function, and also as a reference, those fitness functions can be split in different categories. I won't go through all of them, but through the rest of the conversation, of the talk, I will mention some of them, especially the holistic, automated, and manual fitness functions. Okay, so now that we know the main concepts about evolutionary architecture, let's see how we have used them to implement that framework that I was mentioning before to try to assess the state of our products and use that to make sure that they are modernized. So at the point when we started to try to assess those, define what are the architectural constraints and actually also the fitness functions, we saw that there were many, right? So at this point, the question that we made to ourselves was, okay, so out of all of them, which are the ones I want to choose? Which are the ones that are helpful for me and for my business, for my organization? So after some analysis, looking at the context where our business operates, our products operate, and also understanding what was the main challenge that we have been facing over time, we decided to have these 4 ones. These are the ones that we choose. I mean, if you follow that process, you may choose something different, whatever it applies to you. So why these 4? As I say, we did the analysis and we considered that, considering the challenges that we have, that we want to focus on delivering products with high quality standards first. Second, using products that are using technologies that are fit for purpose and are recommended by us, by our company. Third, we want to build those products that are resilient to threats. And finally, the 4th one is we just want to make sure that they are maintained following our coding and architecture standards. So these 4 functions are not individual ones. They are aggregated. They are made of individual ones. They are holistic fitness functions, as we saw in one of the list of categories, in one of the slides, the categories one, because it covers a wider area, right? Not just an individual atomic thing. Okay, so what's the outcome of running all these functions? So basically, at the end, it's a value, it's a metric that assesses the state of my products, right, in these respective areas. Okay, so at this point we thought, okay, we were ready to start measuring those. However, our products were really, really big and really complex. So we thought that it was better to split the problem in smaller chunks. That's how we came back with the system model. The system model is just a tree representing the structure or the hierarchy of my product, so we can drill down and see smaller pieces of that. It also gives us a common terminology, a common language that we can use to discuss with the different products, right? With the different products, they use the same terminology as we do. This is not something invented by us, actually. It's something that we copy, or not we copy, but we use from other companies like Spotify. So the system model, as I say, was a tree. So at the bottom, we have our components, our deployable artifacts, for example, like a backend Java service, and also resources, like a database. On top of components, we have systems. Systems are a collection of components that cover some some functionality. On top of that, we have domain, which covers certain business area and is a collection of systems. And finally, on top of that, we have the full product, the full feature product. So what gave me this, as I say, was just splitting the problem in smaller chunks. So now I can drill down and understand where the problems are. I can measure at the component level, system, domain, or product. Okay, now that we know the main concepts of our framework, I will go through the functions that I described before and understand what are the principles behind them and how we calculate those functions. Let's start with the quality index. So the two principles behind this metric is quality is not just about testing, it's beyond that, right? So we don't do just testing after the fact. And second, one of the key contributors to the overall quality of our products is the continuous delivery practices. These two principles are extracted from our organizational quality strategy. With this in mind, quality index is measured with two components. First, measured through the practical testability, which measures how testable are our products under certain conditions. And second, the alignment of our products to the continuous integration and continuous delivery practices. With that, we mean things like pipeline length, duration, pipeline health, or actually the incidents that we find in production. Whereas the alignment to CI/CD practices is more like a automated fitness function, practical testability is more manual. We will see the same behavior across the different functions that we use, but you will see that it's something that we want to invest on automation, I mean. So the second function is the alignment. The two principles behind this function are, first, we have a recommended technology stack that we want to promote rather than other technologies. And second, those technologies, when used in our products, we want them to be up to date. So the concept behind this is technology radar. Who of you is familiar with that concept, with the concept of technology radar? Have? Good. So the technology radar is not something, again, that we have invented, something that ThoughtWorks has been created that, and actually it's providing every quarter like updates on those. In our case, it's just a list of an opinionated list of technologies that we recommend in our organization. These technologies are placed across the circle and are represented by these dots there, blips. So these blips contain information about the technology, especially the version, the recommended, and the minimal versions that we will see that we are using those for the calculation of the metric. Those technologies are split or placed around the circle and split in quadrants, which represent the category of the technologies. These are the ones that we use. You can use something different. And then rings. The rings just represent the assessment that we made of those technologies. We have adopt, which are our standard technology, recommended ones, so we use by default in all products, in all software. Trial, technology that we are testing, but we are still a bit unsure about them. Endure, technologies that we were using before, but we are, let's say, deprecating. And hold, technologies that we don't want to use anymore, and technologies that we want our systems, our software, to migrate away from them. This is an example of a real example of our technology radar. You can see all the technologies there. And if you click in one of them, you can see this additional information I was mentioning before, things like the minimal and recommended version. With this information, the technology alignment is measured through the technology consolidation, which measure the alignment of the technology used in each of our products to the ones defined in the technology radar. And second, the technology lag, which measures the alignment of the version of the technologies that we use in our products to the ones recommended in the technology radar. Third function is the security index. Security is key for us because the damage it can create any threat or any vulnerability is very impactful to our business. For that reason, we want to make sure that we are running security activities, things like threat modeling or security testing, but not just in isolation, but as part of our software development lifecycle. So we do threat modeling during the design phase, for example. So with this information in mind, the security index is a bit different than the others because it's calculated in a more sequential way. So it contains 3 steps. First, security coverage, which is actually the result of performing these security activities that I was mentioning before. This security coverage, the performance, when performing these security activities, we just get, as a result, some findings saying, look, there is a risk here, potential risk here that you need to assess, and that's what we do in the following phase. And the last one is the resolution of those security findings that we consider high risk or critical ones, right? So the final one, the final function is technical debt. Technical debt, probably most of you are also familiar with that concept. We have our own version. Traditionally, it's more following coding practices, but we also consider the design practices. So with this information, then the technical debt is made of 3 different components. First of all, alignment to architecture principles. I forgot to mention that when we say design practices, the alignment is measured through our architectural principles, the organizational architecture principles. So this component measures that part. So the alignment of the implementation of our products, how they are implemented, if they are aligned to those architecture principles. Second one is code quality. Code quality is how we measure through static code analysis things like complexity or coupling or maintainability. And finally, the last one is the test coverage that we have in our products. So we have gone through the 4 functions that are part of our framework, that builds our framework. So with this information, just measuring these 4 functions, we can understand what's the health of our systems or our components or our domains. We can give some sort of a score to each of them and understand what's the current state of them, what's the current degradation actually of them. But not only that, this allows us also to set some specific targets on where we want to be. So that, from where we are to the point where we want to be, will help us build those roadmaps, those technical roadmaps, and have these conversations with the business and product stakeholders. So if you remember before, I was saying that we struggle with that, right? So now we have a way to have these conversations. And also, it helps us also prioritize those over other things, right? So we can decide that some products need to be evolved, but maybe some others, they don't. Maybe they are already deprecated. They are all, depending on the maturity of that component of that system. Okay, so we don't want to finish here. Actually, we have some more work to do in our framework. First, we want to make sure that this information is visible to everyone. Wherever it's not visible, it cannot be, it doesn't exist, right? So it cannot be seen. So we want to invest on visualization and make sure that this information is available to engineers through our development portal, backstage in our case, or even to the product or business stakeholders through more traditional data analytics visualization tools, right? Second is we want to invest in automation. I mentioned that before, but it's not automation for the sake of automation, wherever it makes sense. Why? First, because we want to make sure that this is easily adopted by the teams. If it is not adopted, then why, right? We do this. And second, we want to remove any kind of subjectivity that can appear from a manual, let's say, measurement. The last thing is just we work in a continuous improvement way, and we want to get feedback from the different users of this framework so we can make adjustment, add new components to the metrics, remove the ones that we don't consider useful, etc. So after probably like 20 minutes, apart from the interruption, you may be thinking, okay, but what is in here for me? What are the main takeaways that I need to take from this talk? I have tried to summarize this in 3 items. First of all, we know that now we can measure the degradation. You have a mechanism to measure that. And if you can measure degradation, you can manage this. Before, we say that we cannot even manage. We were struggling justifying this. But secondly, if you cannot measure, you cannot improve it. Now you can measure and you can improve depending on the state of your products. Second, it's a very effective prioritization tool. I mentioned that before as well, right? So you can understand what investment you need to do first. What are the products that you need to invest on? But obviously, consciously, right? Some things that you don't want to invest, evolving or modernizing, maybe you don't need to do it. And the last item is, again, something that we have said, is a very powerful communication tool. Before, we were struggling communicating this and promoting this work, but now you have a tool to persuade, influence, and promote all this technical work. So let me finish maybe with a thought. This has been a long journey. We started 3 years ago to speak about evolutionary architecture. However, at that time, we didn't have the tool. We were not equipped with the tools to practice this evolutionary architecture. However, now, after all this investment and after building this framework, we are seeing now the value of it. We can see the benefits. The main benefit is that we are, at least, having those conversations, making the problem visible, and having those conversations with the people that we want to have those conversations. Just the final thing, just considering this framework and trying to integrate that with your software development lifecycle, you can achieve what I was promising, or we were saying in the title of the talk. Just integrating with your software development lifecycle, you can achieve continuous evolution. So thank you very much. That was it.